Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. HAZOP for chemical and process engineers. In this video course, you will learn what is HAZOP, purpose of HAZOP and resources required, HAZOP methodology, HAZOP case study, a real-world example, HAZOP and SIL integration. Please subscribe to the channel. By subscribing, you will motivate us to produce knowledgeable video content for you. So subscribe now before you forget. In the development of process design for chemical process plants, one of the key objectives is to prevent incidents that may cause injury to operating personnel and damage to the plant assets and environment. Evaluation of risks in the operation is a critical step in the process design review. In the past, learning from the operational experience and history of plant incidents in the similar operating plants were used as inputs to develop measures to prevent occurrences that may lead to loss of containment. These measures included safety checklist, standards, safety audit, etc. Hazard and operability study, known as HAZOP, has in the recent times emerged as most widely used hazard evaluation method. HAZOP study is structured examination of identifying how a process may deviate from the design intent. It ultimately leads to evaluation of risk mitigation strategies. The purpose of HAZOP. A chemical manufacturing process consists of a series of individual process activities. The process can be a continuous process or a batch process involving one or more of unit operations. These process activities need to be reviewed from safety point of view to assess the hazard arising from operational problems which can potentially lead to incidents with undesirable consequences. Note, the stress in the study is on the problems arising from operation of the facility. The effective risk evaluation method should go to the root of every process activity and ask what can go wrong and cause an incident in this process step. The answer to this question most often is deviation from design values. HAZOP study focuses on investigating each equipment in the production facility and finding out the ways in which the actual operating condition can deviate from the specified design conditions, which can potentially lead to accidents. This approach of hazard evaluation in the operation of process plants has made HAZOP a powerful tool in the process design development. Simply put, the purpose of HAZOP is to systematically review the process steps or operations in order to identify and evaluate the hazards and recommend the measures to mitigate the risk. This table presents the process parameters that are commonly used in the HAZOP analysis. They include pressure, temperature, level, flow, composition, pH, viscosity, time, speed, vibration, mixing, etc. The deviation of the actual process or operation parameters from the design or specified parameters when the facility or the chosen equipment is in operation are focused in the HAZOP analysis. Resources required for HAZOP study. HAZOP study is a multidisciplinary activity involving experienced team members from process, operation, maintenance and safety, depending on the process. The document required for carrying out HAZOP studies are the updated P&ID, PFD, process description, operating procedures and shutdown interlocks, equipment and instrument data sheets. The people selected should have adequate knowledge and experience in design, operation, commissioning, shutdown and maintenance. HAZOP analysis can be performed on new projects and on any improvement projects or modification in an existing production plant. For a new project, HAZOP analysis is performed when the process design is fairly complete and the design process drawings such as PFD, P&ID, and the operating procedures are available for the team to review. For modification projects in an existing plant, the updated P&ID and relevant PFD along with the process descriptions and operating procedures of the proposed modification schemes are placed before the HAZOP committee for evaluation. HAZOP study methodology. HAZOP is a 5-step process as outlined below. Step 1. Form a HAZOP team. Step 2. Identify the process sections of the system. Step 3. Apply the guide words and consider the deviation from the design intent. Step 4. Identify the risks and its consequences. And step 5. Finalize the actions. Before the commencement of HAZOP, the process plant or a part of the plant identified for the HAZOP study is divided into nodes. Nodes are small process sections of that part of the plant selected so as to keep the focus on discussion manageable. The usual method is to select the nodes as follows. 1. Input streams to the process equipment. 2. Output streams from the process equipment. 3. Process equipment such as reactor, distillation column, etc. 4. Utilities, vents, drains, etc. 5. Reactor recirculation and cooling loop. The HAZOP analysis is performed using a set of guide words. Guide words are words used to guide the HAZOP analysis discussion in order to identify the potential process hazard arising from operations. The guide words facilitate the team members to brainstorm and find out the possible deviations from the design intention during the course of the study. Shown in this figure is a process equipment which is a reactor. The reactant from the reactant vessel is transferred to the reactor under flow control. In this equipment, the process section is the pump discharge line to the reactor. The design intention of the process section is to transfer a predetermined or controlled amount of the reactant to the reactor through a flow control. The process section is taken up for hazard analysis by using guide words. Other process sections in the reactor include the reactor itself, the agitator, the reactor outlet line, heating and cooling system. Every process section is evaluated one by one in sequence to identify the possible deviations from the design intent. The potential hazards and their causes are recorded in a table with proposed action to prevent or mitigate the risk. The list of common guide words are presented in the table below. The HAZOP team should identify the guide words that will best suit the selected process section. The first guide word is no or not. The meaning of this guide word is complete negation of the design intention. The next guide words are more or less. These words are applied to flow, pressure, temperature level above or below the design limits. That is to say, the design intent is not met. The effect of increase or decrease of these quantities or properties are investigated. The next guide word is as well as. This word is applied in cases where all the design requirement is met together with some additional activity, which may be entry of impurities such as air, moisture, or other contaminants into the reactor. The next guide word is part of. This word is used to analyze cases where only part of the design intent is achieved and some are not met. Example of use of this guide word include changes in composition of feed to a separation column or a reactor. The next guide word is reverse. This word is applied to analyze reverse flow in case of pump failure, check valve damage and pump discharge or incorrectly installed. The next guide word is other than. This is applied to deviations caused by activities such as power failure, loss of instrument air, cooling water, steam, inert gas, refrigeration system, and corrosion. It may also include wrong material added in a process step. Before we move on, I would like to make a call to my dear viewers. Your SPEC e-learn channel is one-stop learning and skill development destination for your career needs. Get instant access to useful career-oriented subjects and become knowledgeable and competent. So do not forget to subscribe. Please press the subscribe button now. The HAZOP analysis covers the entire plant or the operating facility in the case of a new plant under design. The plant may have several P&IDs. Every P&ID is individually taken for examination by the HAZOP team. Within each P&ID, process sections are selected as discussed before, and the study is conducted using the appropriate guide words. The discussion or analysis results are documented in a table. The results of a HAZOP study are documented and presented in a table, a template of which is presented below. The table may contain process parameters, guide words used, possible causes for the deviation, existing safeguards if any, and actions required. The HAZOP sequence is presented below. Select an equipment, explain the design intent, select a line, explain the intention of the line, select a possible parameter, apply the guide word, consider a possible deviation, analyze possible causes, examine its consequences, decide on the action to mitigate the risk, apply the next guide word, and repeat the procedure. Repeat the procedure for all the lines connected to the selected process equipment. Next is the HAZOP and auxiliary systems such as heating and cooling for the same equipment if applicable. Follow the procedure below for examination. Repeat the same for all the auxiliaries. When all the auxiliary systems have been examined, the HAZOP study on the selected process equipment is complete. Mark the equipment as completed. HAZOP study a sample exercise. HAZOP study is done with engineers with sufficient experience in the relevant process. Experienced production or process engineers having sound process knowledge in the same process are needed so that the team will receive appropriate replies to the risk-related questions raised. Illustrated in this figure is a chemical batch reactor in which a polymerization reaction takes place in liquid phase. Initially, A fixed quantity of reactant A called starter along with the liquid catalyst is added to the reactor, and the reactor contents are well mixed and heated to polymerization temperature of 125 degrees centigrade. When the required temperature is reached, the reactant B is added continuously. Since the volume of the reactor is fixed, the flow of the reactant B is stopped when the required quantity of B has been fed. The polymerization reaction is exothermic reaction, and the heat generated is removed by circulating the liquid through a heat exchanger as shown. After batch is completed, the reactor products are transferred to another vessel for catalyst removal and further processing. Let us do a HAZOP study on this reactor. First, divide the reactor system into process sections or nodes with clear boundaries. You can identify 7 process sections with boundaries clearly marked. They are given below. 1. The reactant A feed line to the reactor. 2. The reactant B feed line to reactor. 3. The reactor. 4. The product transfer line from reactor. 5. Reactor recirculation and cooling loop. 6. Nitrogen to reactor. And 7. Vent to flare. Let us select the pipeline supplying feed A to the reactor. This is the first process section. Flow is the operating parameter. The guide word is no flow. Possible reasons are 1. FCV fails and closes. The consequences is no reaction and product formation stops. Action required, periodic maintenance of the valves. 2. The second possible cause is feed line rupture. Action required is visual inspection of the pipeline for corrosion, etc. The third possible reason is a feed pump tripped. The action required is to provide trip alarm in the control room. The fourth possible reason is no material in the feed vessel. The action required is to improve the raw material planning. 5. The fifth possible reason is FCV isolation valve is closed. The action required is to strengthen the operating procedure. 6. The sixth possible reason is flow meter error. The action required is periodic maintenance of flow instrument. Now select the next guide word for flow. It is less flow. The possible reasons are 1. FCV malfunctions. The action required is periodic maintenance of FCV. 2. The second possible reason is the feed line leakage. The action required is visual inspection of pipeline. 3. The third possible reason is FCV isolation closed. The action required is to strengthen the startup procedure. The consequence of less flow is production rate decreases and batch time increases. There is no safety risk. Now select the next guide word for flow. It is more flow. The consequences of high flow are 1. Reaction temperature increases due to increased rate of reaction. 2. Reactor pressure increases. These two developments will lead to undesirable consequences such as runaway reactions. The possible reasons are FCV malfunctions and FI error. The action required are periodic maintenance of FCV and calibration of FI. 2. Alarm and shutdown system on high flow to reactor. We have completed the first process section, the feed line to reactor. Next process section is the reactor itself. Let us do HAZOP on the reactor now. In this process section, choose the first process parameter, temperature. It is a critical parameter. Now apply the first guide word more. The possible reasons are 1. FCV malfunctions, 2. Cooling water pressure low. The consequences are 1. Increased rate of reaction, which may lead to a runaway reaction. 2. Reactor pressure increases. These are undesirable consequences with high severity. The actions required are 1. Alarm and shutdown system on high reactor temperature. 2. Periodic maintenance of control valves. Now choose the next guide word for temperature, less, that is low temperature. Possible causes are TCV fails and opens full. The consequences of this deviation is reactant rate decreases and the reactor concentration increases in the reaction mixture. Action required is periodic maintenance of control valves. So far, in the HAZOP reactor system, we analyzed the deviation in flow and temperature from the design intent. Particularly, more flow and high temperature has potential for runaway reaction, and safeguarding system needs to be developed to mitigate the risk. A SIL 3-step system is needed considering the severity of the consequences. The HAZOP also led to the development of schedule for inspection of piping system and maintenance of instruments and mechanical equipment. In the same way, other process parameters are analyzed with guide words and HAZOP is completed. The results are presented in the tables that follow. Briefly speaking, we analyzed the deviation of pressure and agitation with guide words and documented the action that need to be taken to mitigate the risk. Also shown was a HAZOP on two other notes, namely nitrogen input to reactor and vent to flare. I request you to go through the table and spend some time to understand all the deviations and the associated risks. Now move to next process section one by one in the reactor system. Reactant B feed line, reactor product transfer line, and reactor circulation and cooling loop. Complete the HAZOP following the same procedure and document the actions. Once the HAZOP for all the 7 operation sections or nodes of the reactor system is completed, the results are documented as illustrated in the table below. The documented results of the HAZOP analysis should be reviewed in respect of recommendations for safety instrument system or interlocks. Factors to be considered in deciding on the SIS are operational disturbances resulting in economic impact such as loss of production and damaged equipment, loss of containment leading to releases that can pose threat to operating personnel and environment. HAZOP and SIL integration. I would like to recall our discussion in our earlier video titled Safety Instrumented System and Safety Integrity Level, in which we highlighted that safety integrity level for a safety instrumented function is calculated from the hazard analysis. Now in this video you have learned how the HAZOP analysis led to the evolution of the safety instrumented function or interlock needed to mitigate the risk. Thus, it is evident that a systematic and structured hazard analysis method such as HAZOP may be considered as the basis for determination of SIL for the safety instrumented function. SIL assessment commences after the HAZOP has been finished. The scenarios identified as hazardous are subjected to SIL assessment. Detailed quantitative risk analysis is needed to determine whether SIL 1, SIL 2 or SIL 3 safety instrumented system is required for the risk identified in the HAZOP. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.